This is the video about Subway and how to cut the waiting lines.
Hi all, our group will be working on to improve the operation in our very own Subway located in the hub. And the problem Subway is facing right now is with the long queues. In this video, we'll be working on some ways and techniques to improve the production line. And let us get some data right now from the Subway's manager.
Okay, let's start with the first question. Robert, when is usually the busy hour?
Between about 11:20 and 2:40.
Oh, okay. And do you know what is the customer arrival rate?
About 130 to 140 an hour.
Question is, what is the average service time per customer?
The goal is to get a customer served within 2 minutes of them placing their order, and we do well in that.
Question is, what's the average waiting time during the peak hour?
It really can vary depending on how well we're staffed, but I would say 5 to 10 minutes. It can vary. If we're well staffed, if all the students have shown up for work, we've got enough hands to move the line fast.
Okay, and you have two counters, right? The question is, how many servers do you have during peak hours and non-peak hours?
Between the two lines, I have 9 people staffed during the peak hours, and I've been here 10 years, and I've tried as many as 12, and it ends up not being financially smart to have as many as 12. You may think, well, the more people you have, it's going to move it faster. It will a little, but it ends up actually also not paying for itself by having too many people. If I have 10 people on a site, it'll move fast, but you can't afford it. You're going to go on. And so I found that 9 to 10 people is the most, 4 to 5 per side, and I'm usually over there being the back stocker to keep those people serving. So you could count me as one more person. So instead of 9 to 10, it's really like 10 to 11 with me in there.
Okay. And then, what's the strategy that you use to cut down the waiting time?
Well, staff as many people as we can afford to pay, afford to staff. Put staff with their best use. So I mean, when we have people who can take the order faster, we have them there, and so we put people in the position where they move the fastest. And you be doing no prep during the rush. You have all hands on deck. Everybody's making sandwiches, and that's basically the strategy I use.
Okay.
Hi everyone. As you can see from the interview, these are the data we have collected. If you see, this data is collected between 11:20 to 2:40, which is the peak hours. And the average arrival time we have calculated is 135 persons for every hour. And the average service time one server can handle is 2 minutes per person. And the average waiting time is 5 to 10 minutes. And there's only two number of servers in the Subway. This is actually the lambda, and this would be 30 per hour for the mu. This would be the number of servers, m. With this, we can calculate the service utilizations. The service utilization should be 135 divided by 2 times 30. And that would give us 2.25. This number means 225%. So the servers will handle 2 times service more than they can handle. This is clearly the reasons why the waiting line is so long. And next, let us look for the solutions to solve the problem.
So our group came up with 2 ways to improve the production line in Subway. First, let us take a look at the old data. First, we have the M, which is 2, the lambda, which is 135 per hour, the U, which is 30 per hour. So right now, we decide to improve by adding 2 more persons in the cashier to improve the production line. So by adding 2 persons, that means we have 4 servers right now. So let's take a look at this picture. This is the Subway, which has 2 cashiers, and by doing so, the optimizations of this cashier is 225%. By adding 2 more cashier, it will actually reduce the utilizations by using this formula. $1.125. So the utilization is decreased by half, which means that every employees have 100% of utilizations, which means that there is no waste. By adding 2 more cashiers, which means that we can reduce the utilizations by half to 1.125. So this is actually tackling the bottlenecks, which actually reduce the utilization. So right now I will pass on to Melissa to discuss to you with the second method that we came up with.
Alright, so the second method that our group came up with was to decrease service time. And one of the methods was to introduce a pre-order form, which you can involve the customers to check on the boxes that they would like vegetables, lettuce or tomatoes, and pass it to the servers while they are making the bread. So that speed up the process of making the sandwich. And a second method would be to remove the soda machine to be outside. The Subway currently have the cashier to pass transaction of the customer and also serve the soda drink for the customer. One way to reduce the service time was to actually move out the soda machine to be outside the counter, involving the customers to actually serve themselves with the drink. And therefore it will decrease the service time. And for our current situation, we have a lambda of 135 per hour and a mu of 30 per hour. So by actually having pre-order form and introducing the soda machine to be outside, we assume that the lambda will decrease to half, which actually leads you to 60 per hour. And therefore, our system utilization will be 135 over 60 times. This decrease in the utilization will definitely decrease the service time.
In conclusions, our team came up with 2 decisions, which is first, to increase the number of servers, which is the M. Second is to decrease service time, which is the mu. So by doing so, we can actually fully utilize each server to do their job more effectively. So thank you for your time.